So today we're going to look at proportions within triangles, but before we do, let's take a glance at our warm-up here for today. So it says complete the following based on the fact that a over 4 equals 12 over b. So with that, a times b would equal that 4 times 12, which is going to be 48. And then 4 over a, that's that reciprocal property. We flipped that fraction upside down, would be b over 12. A over 12 would equal 4 over b. B over 4 would equal 12 over a. And lastly, b over 12 would equal 4 over a. So that's just a review of some of those properties with proportions that we talked about in the last section. From here, we're going to skip ahead just a little bit to look at some of these proportionality theorems. That's our focus for today. So, I'm going to make this a little bit larger for us. The triangle proportionality theorem says if a line is parallel to one side of a triangle and intersects with the other two sides, then it will divide the sides proportionally. So the example they give here is we can say that RT over TQ would equal RU over US. So whenever we see that we've got these parallel lines here and here, they're going to divide that triangle proportionally. The next one says the converse is true as well. So if the line divides it proportionally, then I can assume that these two lines are parallel. So looking at this, notice whenever we set up these two proportions here, we were never talking about the parallel bases, meaning we were looking at this part is proportional to this part. Sorry about that, guys. And this part is proportional to this part. We never touched those parallel bases. So when I look at this first example here, using the proportionality theorem, I'm not going to touch the 17 and the x for that proportionality theorem. For those, I'm going to have to use what I've done in previous examples where I look at the entire triangle. However, I can use my proportionality theorem for some of the other examples throughout the notes. So because x is on that parallel base, what I'm going to do instead is I'm going to look at the two triangles. I've got 12, 15, and 17. And then if I look at the entire triangle, I've got 20, 25, and x. And because of the parallel lines that we have here, these are two similar triangles by angle-angle similarity, as we talked about yesterday. So I can set up that 12 over 20 should equal 17 over x. So again, 12 over 20 should equal 17 over x. And as long as we're consistent in how we form those proportions, we should end up with a true statement. So when I cross multiply here, 17 times 20 is 340. That's going to be divided by that 12. So I'm going to end up with an x value of 28 and 1/3. So notice we did not use that new proportionality theorem here because we were looking for one of those parallel bases. So we have to be very, very careful with that. Same thing for the triangle over here. Since we're using these parallel bases, we've got to look at these in terms of triangles. So I've got 4 and 3. And on the right-hand side, I have 4 and x put together. So notice that's not 4x, that's 4 plus x, and 8. Then I can set up 4 over 4 plus x should equal 3 over 8. I can cross multiply and get 32 equals 12 plus 3x. So 32 minus 12 is going to give me 20. And then if I divide that by 3, I find out that x is 6 and 2/3. So long story short here, guys, anytime we're using those parallel bases as part of our question, we can no longer use that proportionality theorem. However, looking at this guy here, they want us to find YZ. So that's my x component. None of the information I'm given talks at all about these parallel lines. So this is where that proportionality theorem comes into play, which says 44 over 35 would be proportional to 36 over x. And at that point, I can cross multiply and solve and find my x value. So 36 times 35 is going to get divided by 44. We're going to end up with kind of an ugly answer here. So I'm going to convert this to a mixed number. You could just round that if you wanted to. But x equals 28 and 7/11. Like I said, if you wanted to leave that as a decimal, just put a squiggly equal sign to represent that you rounded. These next few examples here, notice none of the information we're given is on these parallel lines. They're all blank, so that tells me I can just use the proportionality theorem. So looking at this, 6 over 2 would equal 9 over x. Just be consistent in how you set those up. 2 times 9 is going to give me 18, and 18 divided by 6 tells me that x is 3. Same thing here, x over 12, so top over bottom, would equal top over bottom. Cross multiply, 15x equals 12x plus 12. Therefore, 3x equals 12, which means x is 4. Last but not least, I could also go left to right if I wanted to. I just need to be consistent between the two ratios. So if I say 18 over 16, that equals 7 over 2x. Left over right equals left over right. Then I have 16 times 7. That's going to end up being divided by 16. And we find that x is 7. We also have two other proportionality theorems. So if we have 3 parallel lines that intersect 2 transversals, then they also create proportionality. And if we have an angle bisector, it creates proportionality as well. So that part over part will equal part over part. You may want to pause the video here and jot those down, and we're going to use these in the following questions. So we want to find the length of AB. So I'm going to put an x value here. Notice we've got our 3 parallel lines, so those are going to divide that figure proportionally. So I can say 16 over 15 equals x over 18. I could have also said 16 over x equals 15 over 18. I just want to be consistent in how I form that between the two ratios. And if I solve that proportion for x, x comes out to be 19.2 exactly, so I can use that hard equal sign instead of the rounded equal sign. The next two questions have an angle bisector, so I can say 15 over 21 equals x over 14. I can cross multiply, and I find out that my x value is 10. For the next one over here, 8 over 4 would equal y over 6. Now with this one, you might be able to see what that's going to be, right? 8 over 4, that's going to simplify to 2. So what is that y value going to be? It's going to have to be 12. Or we can cross multiply as normal. To sum up, 3 parallel lines as well as angle bisectors will create proportionality between the figures. For these next question here, you may want to put a star by this in your notes. This is one that's a little bit funky. So 15 is the entire length from Q to S. If I told you that x was 10, we would know that Q to R would be 5 because we would subtract that. But since I don't know what that is, this part right here is whatever I get when I take the total minus x. So that's how we're going to set that up. We're going to say 7 over 15 minus x should equal 13 over x. We're going to cross multiply. 15 times 13 is going to give me 195. I'm going to subtract, or rather I'm going to add that 13 to the other side. So I have 20x equals 195. And 195 divided by 20 tells me that x is 9.75. And that gives me that missing piece. So I now know that x is equal to 9.75. You've got two other examples like that here. Notice for number 14, they actually give you the two numbers. So 29 minus 11 would give me 18. So 16.5 over 11 would equal p over 18, and I could solve that from here. However, for this one on the right, they don't tell you how big that section is, so we have to take the total minus the part we already know. So I could say q over 36 would equal 16 minus q over 28. Cross multiply and solve as normal. Last but not least here, we've got some proportions that are happening among these two triangles here, or really these three triangles, because we have three sets of parallel lines. So I could say 6x over 18 equals 2x plus 1 over 7.5 equals 2x over 6. And at this point, I have three ratios that are all proportional. So I can choose the one that I want to ignore, if you will, because if they're all equal, I should be able to just look at two of them. So if it were me, I would probably ignore the one in the middle because it's got a binomial in the top. And then I would just cross multiply 6 times 6x, that's 36x, equals 18 times 2x, so that's also 36x. So in this case, x could be anything it wants to be, right? So with that, I may want to go back and look at some of the other proportions, because in that case, I end up with a true statement. 36x equals 36x all the time. So that's not going to help me solve for x. So this time, I might choose to look at these two here and cross multiply. So 12x plus 6, when I cross multiply the 6 and the 2x plus 1, equals 15x, which means 3x equals 6, which means x is 2. If you really want to be thorough, you could double back. You could look at these two together as well. So we've got 6 times 7.5, that's 45x, equals 36x plus 18. So 45 minus 36 gives me 9x, and we should find out here as well that x is 2. So if we ever end up with a case that's kind of a special case where we have two identical pieces that are equal to each other, that's true all the time. So then we want to double back and look at one of the other proportions that we have, because in this case we had three ratios that we could look at, and one of them ends up giving us the correct answer. Now there's going to be several examples here that are going to have lots of variables to solve for these final few questions here. For the purposes of what we're going to do for this video, I'm going to go ahead and skip ahead just a little bit, but I am going to show you how to set up the first example here. And then for the remainder of the questions, I'm just going to set them up as a proportion and allow you to finish the notes on your own. So for this first question, we have 4 parallel lines. Remember, you want to be careful if you're ever solving for these parallel bases. You want to make sure you look at the entire triangle instead of using the proportionality theorem. So for example, if I want to solve for f, I could say 12 over 15 equals f over 10, and I could get that value of f because none of those numbers represent the parallel bases. However, if I'm trying to solve for d, I would need to say 10 over d equals, so I did 10 over d, would equal 25 by adding those together over 12.5. And then I can cross multiply from there. Same thing if I'm looking at c. I might want to say 25 over 12.5 should equal 30 over C. So anytime I'm solving for those parallel bases, I want to make sure to include all of the components of that triangle. However, if I'm looking for, we've already looked at D, C, and F. Let's look at our remaining pieces here. So I still have to figure out A and B. So if I look at B, B is right here. So I could say 12.5 over B should equal 12 over 15. And I can cross multiply here because those are not involving those parallel bases. So therefore I can use that proportionality theorem. So then we've got B, C, D, and F. We still need E, and we still need A. So E is this component right here, so that's just part of that proportion. So E over 5 could equal 12 over 15, and I could solve. And then lastly, since A is one of those parallel bases, I would need to add all of this together. So I'm going to have to figure out what B is, or I could add all of this together, once I know what E and F are, and figure out that total over A. So I'm just going to write total over A should equal whatever I have for F over whatever I have for D. So in that case, when we're looking at those parallel bases, remember we're thinking about that in terms of the entire triangle, so we want to make sure that we add those sides together. Like I said, we're just going to kind of set up some of these. Since these are our parallel lines here, none of our information is given that represents the parallel line itself. So one option would be 5 over x equals 3 over 6. Same thing for the one on the right. I could set that up the same way. Or I could say left over right equals left over right. As long as we're consistent, you should end up with the same answer, regardless of if you said x over x minus 2 equals x plus 4 over 9, or the way we did it here. For the one on the right, one option you could say is 3x over 7.5 equals 4 over 2.5x. Again, that's not the only option. You could have moved that around a little bit and said 3x over 4 equals 7.5 over 2.5x, and you would end up with the same answer. These final few questions here are going to go over that angle bisector theorem, which says 3 over x would equal x plus 2 over x plus 4. Or I could have said x plus 4 over x plus 2 equals x over 3. Again, consistency is key between the two ratios. So 16 over x would equal 12 over 9. And 6 over x minus 4 would equal 9 over x. Again, your setups could vary here, but we should end up with the same answer as long as you're consistent. Last few examples here are going to be very, very similar to the ones that we just set up, so I would recommend that you try these on your own. Please remember that you can email me if you have any questions or concerns. Thank you so much for your attention and have a great day.